this video, I'm going to explain how to create virtual instruments using the Copilot software on the Databus trainer, and then linking those virtual instruments with the actual hardware or with the signals that are being simulated in the program, which is Copilot. So let's start with opening the Copilot program by clicking on this icon on the desktop, and it'll bring up this menu which will allow us to either recall a recently done project through this option, or we can create a new project. So let's create a new project for creating simulated channels and then linking it to the virtual instruments. For new projects, these are the two options: empty project, where we start without any hardware and then we add the hardware. The other option is using the auto search for the hardware. The program will look for the ARINC 429 hardware or any other Databus hardware and then bring up the option to use that hardware for the simulation. We will use this option because this computer which I'm using has an installed PCIe card for ARINC 429 signals. You can also create a project using this empty project and then use the option to choose a demo card in case you are working on a computer that doesn't have any hardware. It can also be actually done from here. So to keep it simple, let's use this option whether we are using a demo card or an actual installed card. So when I double click on this icon, it'll open the software. I'll maximize the window so we have a lot of room to work. It'll open up the window and it'll show the detected hardware, which is an ARINC 429 card with 8 receive and 8 transmit channels. For the purpose of setting up the channel, this is an option. We can use all the channels. It shows 8 receive channels from 0 to 7 and then 8 transmit channels from 8 to 15. The symbology is based on channel numbering and the role of that channel. So CH1 means channel 1, RX means receive. So this is a channel which is channel number 1 and it can receive ARINC 429 signal. Similarly, this is a channel 11, and it is a transmit channel, so it will actually transmit ARINC 429 data or 429 signals. There's another way of looking at these channels. It is through the Hardware Explorer, and it lists all the channels which are part of the detected hardware. I find it easier to work with Hardware Explorer because the information that we create is visible. So I'm going to minimize or remove this window and use the Hardware Explorer for the purpose of setting up the channel and seeing what is assigned to a channel. It has two parts. One is the channel assignment and the information regarding that channel. Right now there's nothing on it because it's all blank. It has not been set up. And this part shows the status of the channel when it is running. So I'm going to increase the size of this window to have a better view, and I'm going to minimize the channel status and just look at the channel configuration for the time being so that we have a good and a clear view of each channel. Now we can set up any of the transmit channel, but I'm going to go in a sequence and use channel number 8 to set up as HRS, and I'll use channel 9 for the nav information. Now to select any channel, you bring your cursor on that channel and then right click. It'll bring up choices for setting up the channel or controlling that channel. There will be one choice which will be in bold, the other one will be in normal font. This is an intuitive suggestion as to what needs to be done for setting up the channel. So currently all the channels are blank. So first logical step is to set up the equipment ID, that is to define what kind of equipment this channel belongs to. And it is possible, I mean, you are not limited to using just this bold choice. You can use any of the choices, but this is a suggested action by the software. So actually this is we need to set the equipment ID first. I will left click on the equipment ID and it will bring up the list of all possible equipment IDs which are available under ARINC 429 definition. As you can see, when I came to this menu or pop-up window, the hardware tree disappeared. So let me pin the hardware tree after I make the selection. So let me first select the AHRS as the option, and when I click OK, it will set up the channel for simulating AHRS information. So, and then automatically it will bring up all possible labels which can be assigned to that particular type of equipment. To keep the simulation simple, let's just select the three basic parameters, which is the magnetic heading and the roll and pitch information. So if I go down the list, I will find the roll and pitch information, pitch angle and roll angle. So holding the control key, if I left click on pitch and then left click on roll, then all the selected all the three selected channels that I wanted to select are shown here. So when I left click on add selected, it'll add these channels to the channel that I was trying to configure. This is the list of the three channels that have been added to the selected channel. So we don't need that information. I'm going to close this. The hardware tree went away when I was working on the other window. So the reason is that I didn't pin it. So whenever I move the mouse away, it retracts. So to keep it visible, I must pin the hardware tree so that it is always visible. Now we can see the hardware tree. As you can see, we had selected channel 8 as attitude and heading reference system, and we had assigned 3 labels to this channel, which is the magnetic heading, pitch angle, and the roll angle. Now in the same manner, let's assign channel number 9 for the navigation information. So again, I bring the cursor on channel 9 and then right click on it and then set the equipment ID to ILS receiver, which basically will also show the VOR information. So I've selected that option, and now let's again keep it simple and do the localizer deviation, live slope deviation, and VOR bearing. So these 3 labels are selected, and now if I left click on as selected, it will bring up those labels into this channel. Again, this window shows which are the 3 channels assigned to channel number 9. We don't need this window, so I'm going to close it. Okay, so now we have set up 2 channels for 2 types of equipment, the AHRS and the airborne ILS receiver or VOR receiver included. Now we can simulate the data using these 3 labels in channel 8 and the 3 labels in channel 9. Next, I'm going to create the virtual instruments where we are going to show the simulated information from these labels on virtual instruments. So for creating the virtual instruments, we have to go into control view. By left clicking on this, I get the control view, and in the control view, it is a blank control view, so I have to design the instruments that I want to use. So I'm going to go into design mode by clicking on this icon. It is a left click, and now this window pops up, which we don't need for the time being. I'm going to close this. We have to go into the design mode and be able to select from the library the instruments which are already available. So right click in the in this area anywhere, and you will see the option to view the palette. So if I select palette, this area gives me the choices as to what I want to design. I want to create aircraft instrument, which is already in there. So first I click on this symbol, the aircraft symbol, and now I'm in design mode and I can create. So when I move the cursor into the design area, it allows me to define the size and location of the virtual instrument that I'm going to create. Now, while holding left button of the mouse, you can define the area of the instrument by moving the cursor. So I have pressed the left button, and now I carry this cross to define where I would like this instrument to be. And what I'm doing is I'm creating, as you can see on the left, the channel which is highlighted is channel 9. I'm creating an instrument that can be linked to channel 9, but I can also create a channel that later on I can link to channel 8. So let's go in a sequence. We had created the channel number 8 first, so I'm going to assign this particular instrument to channel 8, which is AHRS. Now, by drawing this rectangle, I have defined the area where this instrument is going to appear. If I right click while the cursor is in this defined area, then it'll give us the choice to assign or select the properties. So let's go into the properties, and in the properties we have the choices of various instruments which are pre-stored. Of course, it is possible to create or add to the library and create more instruments, but we are going to use what is already in there. So this is going to be the artificial horizon, and these are the various choices and options. I'm going to click on artificial horizon, and you will see that the image, the instrument that I've created right now, it doesn't have any indication or doesn't define what it is. So as soon as I left click on artificial horizon, it'll become an artificial horizon. So apply and click OK. So we have created the first instrument, which is the AHRS display, the artificial horizon. Now, we can create, if I click left click anywhere, we will get out to the designing of this particular instrument, and now we are ready to add the other instrument. So again, click on this aircraft symbol to bring up the aircraft instrument, and now draw the area where you want this instrument to appear. So I'm going to draw or define the area where this instrument is going to be placed. Again, it brings up a blank instrument, and now by going into the properties, by right clicking on the mouse, I can define what kind of instrument it is going to be. So our next channel is for navigational information, for localizer deviation and glide slope deviation and VOR. So I'm going to select HSI for this particular display and apply, and when I click OK, clicked on HSI, then apply, and then click OK. Now we have an HSI display. So we have created two instruments which will relate to the two channels that we have set up just a little bit ago. Okay, now we are done with the design, and now we can get out of it. So for doing that, we have to click on the design button again, and it'll take us out of the design mode. The way to distinguish between design mode and the view mode is these white dots which are visible, that shows it is a design mode. When we click on the design mode button again, it'll go back to the control view, not the design mode. So I clicked on it and all those white dots are gone. Okay, I'll just right size this control view so we have just these two instruments and we have some empty space for other stuff. Okay, so now we have this display and we can just position it so that we have some blank area for other work that we'll try to do later on. Okay, now I'm going to show how the instruments which we have created can be linked to the data being generated by these channels. In order to do that, we have to use this option of new link. So when I left click on this, it has it brings up this menu. It has two sections, one on the left and the other is on the right. The left one is the source and the right one is the sink. In this case, our source is the channel and the sink is the instrument that we have created. So let's link the attitude and heading reference system outputs to the artificial horizon, and for that we have to pull down the details of the PCIe card showing all the channels. So now if you go down on the list, we will find the channel 8 that we had set up as the AHRS, and we have these parameters. So let's select pitch angle that we want to link to the artificial horizon. Again, this is the control view choice, and then we have to assign it. Now there are two numbers here, AIR CTRL, instrument control view and instrument number 1 and number 2. These numbers are automatically assigned based on the sequence in which those instruments were created in the control view. If you remember, we had created the ADI or the artificial horizon first and then the HSI. So in this list, number 1, AIR CTRL1 is the artificial horizon, and the number 2 is the HSI. So let's pull down the menu for the first instrument and let's select, we have already selected actually, the pitch angle from this left side, and then link it with the pitch display on the artificial horizon. These are the various lists, so let's go down and find where is the pitch angle. Artificial horizon pitch, that's where we want to link it to. So we have selected the sink and we have given the indication as to where it is supposed to display, and click OK. Now we have linked the pitch with the instrument. Similarly, we can select roll and create the link go back to the control, go back to the card, the channel number 8 and the role information. So open up this, select role as the source, and go back to the control view, select instrument number 1 and look for the artificial horizon role. So let's go down the list. Artificial horizon role is right there, so I've selected that, and if I click OK, so now role is linked. Just to check that the link is okay, we can try to see whether that link is working. So we run the program, we run the simulation and change the information in pitch and role and see whether actually it is linked and whether the instrument responds to the data that is being created. So I'll run the simulation and then I will try to change the pitch angle. So select the pitch angle by left click and then right click on it and use a quick control to change it. So slider is one of the quicker method. I will just move this away, and now let's see if I change the pitch angle using the slider by left clicking and then moving it with the cursor with the mouse. Does it change? It doesn't. All right. So it is not linked. Okay, we have created the two instruments, and the two channels have been set up to communicate with these two instruments. So I'll show you how we can link the ARINC 429 data created by these channels with the two instruments that we had created. So that is done by using the link, which basically defines what is the source of the data and where is the sink of the data. So when I open this option by left clicking on this button, there is a screen which has two parts, which is the source and the sink. As you can see, the source is these two channels. So first of all, let's expand the PCI card channels so we know which one we are setting up. Now we are going to set up channel 8 first. Okay. In channel 8 there are three parameters: the magnetic heading, pitch and roll. The magnetic heading has to be linked with the HSI, and pitch and roll are to be linked with the artificial horizon. So let's do pitch and roll first. By selecting pitch angle, let me expand it. We are using the simulated signal, and we will vary the value of the pitch angle to see the effect on the display. So we select the value from this label. There are various items to be selected. We select value, and then we go down to the control view and we will select or link the parameters that we want to show on the simulated instrument. Now in control view there are two instruments, 1 and 2. The numbers are assigned automatically and they are in the same order as the instrument was created. If you remember, we had created ADI first and then the HSI. So this air control 1 refers to ADI and air control 2 refers to HSI. So we are going to link the value assigned in the channel, simulated channel for pitch angle. We are going to link it with the artificial horizon pitch angle. So let me pull down these values, and now let me select the right parameter. So AH is artificial horizon, and I'm looking for AH pitch. So there it is, AH pitch. Now what it shows is the value that we are going to set in the simulated channel is going to be displayed on the artificial horizon pitch. So now if I click OK, that link will be established. It is done. In the same way, we will assign role to the artificial horizon by going into the new link menu, and again in the same manner that we did earlier, we will select the roll angle value, the roll angle value, and link it with the artificial horizon roll. So I'm going to expand this, artificial horizon roll, AH roll. There it is, AH roll, that's the parameter, and if I click OK, then that link is established. The third item in channel 8 is magnetic heading, and that is to be linked with the HSI. So let's go into the new link, pull down the details of the hardware, and go to channel 8 and select the value in the magnetic heading. So now it is selected, and then let's link it with the instrument number 2, which is the HSI, and we will go down until we find HSI related items. So HSI compass, HSI bearing, I think. Let's go down further. Yeah, there it is, HSI heading. Oh, HSI heading right there. So we link it with the HSI heading, and when I click OK, that link is saved and established. So now we have created the links between the three parameters with the instruments. In the same way, we can establish the link with for the localizer, glide slope, and VOR. So the same process, we go into the new link option and select the channel as well as the label, and then link it to the instrument. So you can, I'm not going to talk while I'm doing that, so but I'll show the process. Okay, we have established the localizer deviation link with the HSI deviation. In the same way, we can establish the link between glide slope deviation and the HSI deviation for glide slope. So again, the same steps that we have done before. We find that channel here, and again I'll do that while you watch this process. The glide slope value linked to the HSI glide slope deviation. Again, the instrument number is 2, and we will go down the list to find the HSI glide slope. There it is, HSI glide slope deviation. Okay, so now we have created the link between the simulated channel and the HSI glide slope deviation. Okay, now we have to link the VOR indication on the HSI. So choose the link by going down to the same channel where we are creating the simulated VOR information. Again, we select the value from the VOR bearing and link it to the HSI. Alright, number 2, let's see what is the okay, so we are at HSI and it'll be HSI course. Let's see where it is. HSI compass, HSI course heading. Course heading is the choice. Okay, now we have created the link between all these 6 parameters with the 2 instruments, and now when we run the simulation and we can change the value and we can see the effect of the changing value on the display. So by clicking on this green arrow, I can start the simulation. Now the simulation is running and I can make a change here in the parameters. So magnetic heading, by right clicking on this, we have several ways to control the value. So I'll use the simplest one, the slider, and let me move it away to this side so you can see the effect. Okay, now this is the magnetic heading control, and if I change the heading using the slider by clicking on the left button of the mouse and then dragging this arrow to any other value, you will see the change. So you can see the change in the heading of the magnetic heading shown on the HSI. So that was one item. Now let's do the same for the pitch angle. Right click on the pitch, do quick control, slider, and now I bring the slider to this side, and now I change the pitch angle either to positive value or a negative value, and you will see the corresponding change on the artificial horizon. Let's do the same with the roll angle. Right click on this parameter, use the quick control to vary the value, and then see the effect on the display. Alright, so now I'm going to change the roll angle, and you can see it responds to what is being changed by using the quick control. So now we know that these 3 parameters are linked to the instrument, and the instruments respond to the changes that we make in the transmitted data. We can do the same thing for the other 3 parameters, which are the bearing, omni bearing, and the localizer glide slope deviation. So let's start with localizer deviation. Right click and use quick control. So if I change the localizer deviation, you will see the change in the deviation. The deviation bar here is moving as I move the slider to the right. So that's the response on the instrument based on the data that we are changing in the simulated stream of Airing 429 serial data. Okay, now the next one is the glide slope deviation. Use the same procedure for changing the data for the glide slope. And you will see when I change the slider, it will change the location of this glide slope arrow. There you go. You can see it is being changed. So the last item to see now is the bearing. All right, so let's use the same procedure for changing the bearing. I'll move it out of the way. And now if I move the slider, you will see the change in the VR bearing. That's it. Okay. So that's how we can set up the channel, we can set up the virtual instruments, and then we can simulate various indications on those instruments. In the same way, you can create other virtual instruments and then link the data value to those instruments and have a display of the information which is being simulated by the card, and then see the effect or see the values on the created virtual instruments. This is the simple procedure for setting up these channels. Now, as I mentioned in the beginning, I'm using the installed PCI card. You can also work on a computer after installing the Copilot software, and without having the physical card, you can use the demo card or virtual card for the purpose of creating the project. So let me save this, and then I will get out of this project, and then I will show you how to create your own simulation using the demo card. Okay, it is trying to, these windows are appearing because it is trying to save the quick controls that I created, which I don't want to save. It is not really needed. So I'm going to, it's going to continue with this. So let me just get out of here. Okay, first let me remove these quick controls so it's easier to save. Because it is not really necessary to save all these quick controls. You can bring up the quick controls whenever you're running the simulation. So I just want to keep the project simple and just save the main part of the project. So now it is much easier to save. I'll save this. Okay. There is an option to save as well. So I just saved it as project 3. So I'm going to, after saving this, I'll get out of this project, and then I will show you how you can create your own project using a demo card. So restart the Copilot 7, and then create a new project, and we can use any of the two options. Well, let's use this option. And then from the hardware options, 429, and And now we can select a demo card, add demo. So when I do that, it will bring up a demo card, which is here, which is showing all the channels available in a demo card. It has 4 receive channels and 4 transmit channels. On the top, it is also showing the PCI card channels because there is a card installed. But if you are doing it on a computer where there is no PCIe card, this portion will not be there. So you will see only the demo card option, and then you can set up the channels and virtual instruments using the demo card. And by using the same procedure that I described previously, you can create your own channels, and you can create your own virtual instruments and link the channels with the virtual instruments, and that will simulate what we just did using the actual hardware. In case there is any question, you can always contact Aerotrain, and we will be happy to assist you with the usage of this databus trainer. And the software that is installed is very, very capable software. It has many features, and it is possible to do some exercises using 1553 protocol and the Weather Radar 708 protocol. This is 717, which I believe is used for the flight data recording. So there are various protocols that are possible, and you can do simulation of these channels as well. But the main focus of this trainer is on adding 429, and that's why the hardware installed is also a 429 card. But you can add additional hardware later on, and you can do the demo card simulation for the other protocols. Thank you.